So welcome everybody. This is the second in our international seminar series, our HearMus series. This is a monthly forum for the discussion of a broad array of topics around music and hearing health. What we want to do is to celebrate the state of the art in research on music perception and hearing impairment, hearing aids and music, individual differences in music perception and production, audiological practice, and all sorts of different topic areas and approaches relating to hearing health. So thank you for being with us today. We've got two speakers today, Professor Kai Siedenburg and Dr. Samuel Kuth. And yeah, just want to give them a warm welcome. Kai Siedenburg co-runs the seminar series with me, and he is a professor of communication acoustics at Graz University of Technology and a fellow at the University of Oldenburg. After studying mathematics and musicology in Berlin and Vienna, he obtained a PhD from McGill University in Montreal on the topic of timbre perception. After this, he was awarded a Marie Curie Fellowship to study music perception and cognition at Oldenburg, where he went on to direct the Music Perception and Processing Lab and become principal investigator in the Hearing Acoustics Research Centre. Kai specialises in auditory scene analysis and how normal hearing and hearing impaired listeners make sense of sound. So we're really looking forward to your talk, Kai, and some lively debate and discussion afterwards. If the audience can have a think about questions and either put them in the chat or be willing to come on at the end of the talk and pose your question to Kai, then we'd be really grateful for that. Okay, take it away, Kai.
Thank you very much, Alinka. It's a great fun and privilege to talk to all of you. I've seen many familiar names in the audience, so it's really nice to connect this way on these topics that are of interest to us, so hearing health and music. And my talk today is specifically on musical scene analysis of listeners with diverse hearing profiles. I've called it an adventurous way an update, but I would also offer you perhaps a bit more interesting subtitle, which could be something like this: a collection of surprising and unsurprising findings. So this is what to expect from my talk today. Perhaps you don't find it surprising what I've got to say. That's of course completely subjective here. Before I start, I'd like to say a big thanks, or extend a big thanks to my team. Most of them are still at the University of Oldenburg, and today I will talk about work mostly from these three folks, Michael Bürgel, Robin Hake, and Arvin Benjamin. And yeah, it's really the very nice collaboration between all of us that make this work happen. All right, let's get started. Hearing aids and music. I would like to start this talk with a nice quote that I found on the auditory list a while ago. It remains anonymous here, but this person said on the list, "Oh, and note that the primary goal for hearing aids is speech. Understanding and often hearing aids process music as something to remove. This is a separate, interesting subject for a good discussion another time." And I guess now is another time, so now is the time to discuss this topic properly. To take this discussion to another level, here's our favorite Alinka Greasley, writing on this topic: hearing aid users and audiologists' experiences of music remain mixed. In the absence of formalized training and optimizing hearing aids for music, there is a need for systematic research relating fitting strategies to clinical outcomes. All right, so this is the background of this talk. Hearing aids and music is certainly a topic that has not been investigated so much, and here in this talk I would like to take an approach that's grounded in perspective of auditory scene analysis. Okay, so the agenda is I'll give a brief background on auditory scene analysis and what that is. Not everybody here in this forum might know this. Then I'll talk about effects of hearing impairment on MSA, which we call musical scene analysis. And then I'll talk about musical scene analysis and sound quality ratings and hearing aids and MSA. Okay, so let's start with something that at least I find surprising, namely the construction of auditory reality, which is auditory scene analysis. So in case you're a realist, then you might find it surprising that our auditory system constructs something like which we could call melodies, just on the basis of different time constants. And just to appreciate this wonderful phenomenon, probably most of you have heard something like that before, but I'll just, for the fun of it, I'll just play it once more. Here's the basic streaming phenomenon. So this is a basic phenomenon of auditory streaming. In the first instance, you probably have heard one melody, and in the second instance, when the inter-onset times got smaller, you heard two melodies. So in the fast case, those tones streamed into different melodic voices, so to say. So just on the basis of inter-onset times, the auditory system creates or constructs different representations of acoustic reality. And this is something that has been deeply described in Al Bregman's book, Auditory Scene Analysis, a classic, of course, and later on in the musical domain has, for example, been further explored by people like David Turon in his book from 2016, and people like Stephen McAdams as well. Here's another basic illustration of this phenomenon. So you will hear a melody, or perhaps also two melodies, and you could, for example, type in the chat as soon as you recognize the melody. Probably most of you, or many people of you, know this melody, but it's a nice illustration of the effect. So in the end, it was very clear. Mary had a little lamb, and what happened was you had these two melodies interleaved, and the pitch separation between those two melodies was increased from trial to trial, and eventually you would be able to hear or recognize this familiar tune. And this works not only in pitch space, but for example, in other dimensions as well. It works in timbre space as well, and it works also, of course, also shows effects in with spatial separation. All right, and it has been formalized and measured in this paradigm called interleaved melody recognition, initially proposed by Bay and McAdams, where you have a target melody and a distractor melody, and then you are supposed to recognize the target melody in the distractor melody. And what we see here then on the x-axis is if we increase the frequency difference in this case, so the pitch difference, then regardless of which order the melodies are presented, the perceptual ability to separate these two melodies increases, right? So this is a basic approach of how to objectively quantify musical scene analysis abilities. And based on this operationalization, we see that the feature difference or the auditory cues that differentiate the target and distractor play a significant role here in this task. And what we're about to do with the tasks that I will present later on is to extend these types of paradigms to potentially more ecologically valid or realistic scenarios. Okay, so why is this important? Well, in speech, it's very obvious why auditory scene analysis is important. Here, it's as you all know, it's called the cocktail party phenomenon, and it has been explored quite deeply by research on speech, starting with Colin Cherry. And the basic scenario or the basic setting is quite similar in speech and in music. You start with sound sources that make sound independently, but then these sound sources overlap in time, but also in frequency. So it's a non-trivial problem to represent the sound sources independently. And then the question that we're asking today is, how do normal hearing and hearing impaired people make sense of these mixtures, especially given that they have different representations of different fidelity, one could say. In music, we would be interested in something like source separation, and in speech, we would, of course, be interested in speech of a target speaker or something like that. When we look now at the music psychology literature, I think one could make the case that there's a scarcity of realistic musical scenario assessing scene analysis performance. And we could also argue that hearing impairment has been overlooked for quite a while. Okay, so this is the background. And now to a potentially unsurprising effect, namely the unsurprising effect of hearing impairment on musical scene analysis abilities. So I already alluded to the well-known cocktail party effect, where there we see that people with hearing impairments have special difficulty understanding speech in noisy environments. So the question is, how does this extrapolate, or how does this translate to music? When it's about musical scene analysis, do we find also these difficulties of hearing impaired listeners? And here I would like to give you a brief overview of the literature so far. So one of the first studies that came up with proper tests of music perception of hearing impaired listeners was the adaptive music perception test by Kirchberger and Russo. They used synthetic tone complexes, and I think there's still a MATLAB toolbox available for that, but the sound quality, obviously, if you generate sounds with additive synthesis, then it's not very realistic. What they found was they basically divided music into different dimensions: meter, harmony, melody, and timbre. And then controlling for age, they found that pitch discrimination was significantly affected by hearing impairment, intonation discrimination was affected, and MCR, which means melody to chord ratio. And so this thing is closest to what we would call scene analysis, because it tracks the ability to listen to a melody that's sort of embedded in a chord. Okay, a while ago I did a similar thing where I tried to go one step in the direction of more realistic scenes. And there I took a melody in the upper case here. We looked at a pitch sequence task, so sort of a minimal melody. Then this was played in with a particular very simple accompaniment. And then people needed to say which melody, a comparison, and a standard matched the melody in the mixture. And we did the similar thing with timbre, in the sense that here now it was the timbre between the instruments that played the melody that differed, right? And then one needed to say whether the mix contained flute or trumpet timbre. And this was an adaptive task, so we tried to approximate a 71% threshold. And if we just take a brief look at the results, then we get this picture here. We basically see that we have, for the on the y-axis, we have the SMR, the signal to masker ratio, which is basically the equivalent of speech intelligibility threshold. And then on the y-axis, we have different masker types. So for the piano masker, for example, we have a bigger separation here between older hearing impaired and younger normal hearing listeners compared to the other maskers, and the least separation for the noise masker. And then interestingly, for the timbre task, we have this huge separation between older hearing impaired and younger normal hearing for the piano masker, which means for this impulsive piano sound, when it is used as a chord to mask a melody, you have the decaying temporal envelope, and people seem to be able to listen into the dip of this impulsive masker and then extract the information that's there. And especially in the case of timbre discrimination, then they can extract the relevant information. So this tells us that hearing impairment is actually a big issue in musical scene analysis, and these are big effects, 10 dB. Then normal hearing listeners are especially good for the piano masker because they can utilize these temporal gaps, and hearing impaired listeners cannot as easily make use of these segregation cues. So they have difficulties making use of the full affordances of the signal, so to say. Okay, so this was an interesting test, I think, but it also had its drawbacks in the sense that, for example, we needed to remove 7 older hearing impaired listeners because they were simply not able to do the task properly. So it was not something for everyone, so to say. All right, now let's come to the more current work driven by Robin Hake, where we revisited this idea of testing musical scene analysis ability. And the requirements we here had was we wanted to go for an adaptive test, for a realistic test, and it should encompass a wide range of ability levels. So we didn't want to leave anyone behind, so to say. And we came up with a very simple paradigm, which is a detection task. You hear a target sound, and after a pause, you then hear a mixture, and you're supposed to tell whether the target was part of the mixture or not. I play you some examples, and you can decide for yourself whether it was part or not. Yes, it was part. Second example. Nope. A third example. Okay, so here was again part of it. Obviously, we had also different signal to masker ratios here, and thus we're able to operationalize a wide range of ability levels. We used an online calibration approach with over 600 listeners listening to our items, and then had a validation session in the lab with around 90 listeners. Finally, so in the final version, the test takes around 5 minutes with 30 trials plus instructions, and we get a reliability test-retest correlation of around R equaling 0.7. And it's available also in different languages if you wish. And here's your QR code if you like. Okay, so that's now our test of musical scene analysis ability that Robin Hake has developed. And here are some applications of this test. So we now look at younger normal hearing listeners in blue, older hearing impaired listeners in yellow, and older, well, okay, there's a typo, sorry for that. Older, this should be older normal hearing. And older hearing impaired listeners in gray. And the question is, how do hearing thresholds affect MSA scores? So their scores. These MSA scores are centered at 0 according to the calibration sample. So sort of our normal listener would be at 0, and then it's distributed according to a standard normal distribution. So if you have a score of 3, you're really good. All right. In this test, no one got a score of 3, but we see that certainly young normal hearing listeners were way better than older normal hearing listeners. So age does seem to play a role here. But then the older hearing impaired listeners showed this strong decay as a function of hearing thresholds. Okay, and obviously many different determinants or many different factors can determine which can determine MSA scores here. So we used a nonlinear model to try to disentangle this decision tree model here. And what we got from this model was an indication of feature importance. And here we saw that the hearing thresholds indeed are the most important variable, followed by a musical training index, which is the gold MSI that many of you know. And then on third place, we got age, and only on fourth place, we got an index of working memory. So what we see here is that hearing loss is the most important factor in MSA, independently of age. And so this is what I would call perhaps the unsurprising effect of hearing loss on MSA. Just to give you an overview of these different MSA tests that I mentioned, I haven't talked about this study here for the sake of time, but yeah, for the studies that we just covered, there are pros and cons, but in my opinion, the one by Hake and colleagues shows these properties of realism, adaptivity, and so far it seems to be feasible for all listeners. We even have pilot data where we tested cochlear implant listeners, and it seems to work very well with those listeners as well. And yeah, just to map the literature in this domain here, if we look then at the effects of hearing impairment, we basically see that all those studies found consistent effects of hearing impairment. So we really have strong converging evidence that hearing impairment does make a difference when it comes to musical scene perception. Perhaps unsurprisingly, as one could say, because we already know this from speech. But of course, we needed to see this in music as well, empirically, or we needed to test this empirically. Okay, let's go on to something that could surprise you, or at least it surprised us, which is a divergence of MSA, so musical scene analysis scores, and sound quality. And the first thing that I'd like to mention here is also part of the paper with Robin. Here we had a second experiment where we presented sounds or mixtures with different stereo panning settings. So in the first setting A, everything was mono. And in the second setting, everything was panned, the mixture was panned according to a 90 degrees angle. So this should be now 90 degrees. It's a bit too broad here. And in this in the scenario C, this is 180 degrees. And then we also had a scenario D where the target sound was not where it was played as a target, but sort of replaced by swapped with a different sound, right? So there was a big bit of spatial surprise in scenario D. And what we found here is displayed in this graph. On the right-hand side, we see the score for individual items. So the individual dots are not participants, but individual sounds. And in the case when the target was not in the mix, we have the orange bars here. And in the case the target was in the mix, we have the blue ones. And let me draw it like this. So what the statistical model eventually told us was that in the case without the target in the mix, there was simply no effect of spatial separation. And in the case with the target in the mix, there was this small effect. But this is, so I find this surprising, this small effect size, given that spatial separation and spatial layout plays such a huge role in music production, right? And if we would have had people rate these excerpts according to sound quality, my assumption is that we would have gotten a much stronger effect in terms of sound quality. But apparently we're not able to see this in terms of our MSA data here. Okay, so that's one finding regarding the divergence of quality and MSA. Here's another. In this case, we had spectral manipulations on our mixes with rather drastic results. So on the x-axis, you see here different percentage values of the so-called EQT transform. EQ transform, the EQT, which adjusts the spectral weighting of mixes in drastic ways. And at 100%, it doesn't do anything. So that's the original mix. But then if you go to 200% or if you go to 50%, it changes the mix. We don't have the time to talk about what it does exactly, but you can trust me, it sounds very different. And what we find here then is that on the left-hand side here, young normal hearing listeners are also heard this. So in red, we see their quality ratings of these different mixes. And in blue, we see their MSA performance in the same conditions. So we basically find that, especially for the EQT settings above 100%, we have this strong divergence. The MSA performance seems to be robust, whereas the quality ratings are quite sensitive to this manipulation. And we find the similar pattern for the old hearing impaired, where the quality ratings degrade, but the MSA ratings degrade to much smaller extent. And then if we look at the average MSA scores for every individual and at their average quality ratings, we find that we have a significant correlation between MSA performance and quality ratings for the older hearing impaired listeners, but not for the younger normal hearing listeners. So for the older hearing impaired, it seems that the MSA performance affords also for or is associated with better sound quality assessment, but we don't see this with young normal hearing listeners. Okay, so this is this was my second point on this divergence. Now comes the third point on the divergence of quality and MSA performance. And this is on the topic of hearing aid dynamic range compression. And we're very lucky to have this collaboration here with Christoph Le Simple and Volker Kühne from Sonova. And what we looked at there was how do different compression settings affect our MSA task. Obviously, modern hearing aids have a compressive regime where they squeeze the input level to a smaller output level. And you can do so with different time constants, obviously. And in our study, we had the time constants that were used in this previous paper by Chen, fast dynamic range compression with attack times of 10 milliseconds and release time of 60 milliseconds, and a slow regime with 1.2 seconds and 7.1 seconds. Okay, so the question now is, what works better for music? Here are our results. On the y-axis, you again see the musical scene analysis scores. So 0 would be our average listener from the calibration test set. And let's start here in the middle of things. Our average position here is at, let's say, minus 0.7. So our listeners are worse than our average listener in the calibration set. And then if we go to slow compression, it doesn't really change much, right? So slow compression doesn't seem to improve MSA scores, but if we now go to fast compression, then there's a significant effect. And as you can also see here in the results, there's obviously quite a bit of individual variability. So what we do see is hearing aid amplification generally improves MSA, but we see somewhat unexpectedly that fast compression works best in this case, and we see individual differences. And just to understand why fast compression is the winner here, so to say. Here we see we see the temporal envelope of a target sound and accompaniment sound, one of those stimuli that we used. And now say we have fast compression active, then we are able to use these dips and here where we have a good signal to noise ratio. But when we have slow compression, this is not possible. So this is likely this is the best explanation, I think, for the advantage of fast compression for this type of task here. Now, if we compare this to our quality ratings that we also collected in this experiment, we have the following results. So on the x-axis, we have the musical scene analysis score, and on the y, we have quality ratings for these excerpts. And then we find that the unaided condition is in the left part of this plot, and then we optimize musical scene analysis with fast dynamic range compression, as I just said, but the quality ratings are optimized by slow dynamic range compression. So again, the quality does something else compared to the MSA. And here's a look at individual benefits. On the y-axis, on the x-axis, you have MSA, sound quality ratings, and SRT, so speech recognition threshold using the Göttingen sentence test. And this color map gives you an overview of how the individual participants benefited most, or with which condition, hearing aid condition, they benefited most. And in gray, we highlighted those cases where it was statistically not really clear. And then what we see here for the MSA part is that obviously there's a lot of green. So this means that fast dynamic range compression here works best, as I just said. Sound quality is pretty much dominated by our blue tiles, which shows us that slow dynamic range compression here is preferred, and the same holds for SRT, so for the speech condition. All right, so from this we can conclude that also individual differences play an important role, and that obviously there seems not to be something like a one-fits-all strategy to work in this case. I think I'm already towards the end, or I'm already almost done. So here's the summary. Hearing impairment negatively affects MSA, perhaps unsurprisingly, because we already know this from speech, but here we now see that there's a lot of studies now that show that musical scene analysis is also negatively affected. We see that hearing aids improve musical scene analysis and sound quality, although you can't use the same hearing aid setting for this. So if on average our average subject needs different dynamic range compression settings to optimize MSA and sound quality. So that's an interesting, unsurprising divergence. And what we also see that, of course, individual differences are a major part of these results, and task specificity, of course, as well. I'd like to close with a few questions, because I find questions more interesting than answers. So regarding these observed MSA scores and their robustness to certain manipulations, we saw, for example, that spatial separation didn't really change much MSA scores. We saw that spectral manipulation didn't change much. the question remains whether this reflects a general property of musical scene analysis and the available acoustical cues. So for example, these cues could be so redundant that you really need to change a lot to reduce MSA. This could be one option or one hypothesis. Alternatively, you could also say that this pattern of results reflects the constraints of our specific tasks, and this could be an interesting thing to discuss. So we would need to come up with more refined tasks eventually. Secondly, I think that's of course the big one, but it's an interesting question. What do people with diverse hearing profiles actually want from multi-source music? Multi-source music, polyphonic music, it has so many affordances that it's really hard to disentangle where we need to go. Here we took precisely defined perceptual tasks. And you could argue that we need these defined tasks to study this topic and especially to improve hearing aid technology. But you could also ask the question whether we need a higher dimensional perceptual space, so to say, to account for this situation, and whether one would need to think of sort of multi-objective optimization, so to account for multiple criteria that would need to be optimized at the same time. Okay, so this is some food for thought, and I'll leave it with this. Thanks to you for your attention, and I'm happy to discuss questions.
Thank you so much, Kai. That's really fascinating, and it's so great to see the evolution of the different studies over time and the way that you build and take those steps forward and just finding out incrementally a bit more each time, and obviously that adaptive test and the way that can be done in a short time scale is a great move forward in the field. I think there's just one question in the chat at the moment. I do have a few questions. I don't know if while people are thinking, we could take that first question, which is from Nick Besfeld, and he was wanting to know about whether overall loudness could have played a role in sound quality ratings within your experiments.
Yeah, that's a good question. Loudness is always, of course, a major factor to control, and we controlled stimuli according to level, which is not the same as loudness. And people also gave ratings of loudness in that I didn't report on. But it doesn't seem that those ratings really explain everything that we have in the quality ratings. So these seem to be two different pairs of shoes. Unfortunately, I don't have the data now in my presentation, but yeah.
Okay, thank you, Kai. Could I invite Ian to come on and ask your question?
Sure, thanks very much. Thanks for a really interesting talk. I think I missed it on the way through, but when you introduced the spatial separation into the MSA task, did you cue people to listen for the target sound in a particular location that was consistent, or did they not know where to listen spatially?
Yes, let me just switch back to that part. Wow, I even got my crazy drawings here. So we cued people in conditions A, B, and C with consistent spatial locations. So if you, for example, look at condition C, you have the piano cue. It comes from -18 degrees, and then in the mixture, it also comes from -18 degrees. And we thought, okay, this would serve or guide their spatial attention, but apparently it didn't. It made a bit of a difference, but as I argued, this was a surprisingly weak effect. Also, there was no effect whether the cue location was consistent, right? So there was no real big difference between C and D, and if there was an effect, it went in the wrong direction. So condition C should have been worse than condition D should have been worse than C, but it wasn't. So that was a big surprise.
Yeah, thanks for clarifying. It's definitely surprising.
Let me also mention we currently have other data collected by Simon Jakobsen in a different setting where we don't use this MSA task, but use an instrument identification task. And I could have just put this on here as well, but it was out of time, so I left it out. But it basically tells us the same story. So we don't find effects of spatial separation on instrument identification, but we do find effects on sound quality ratings. And this is a completely different spatial rendering approach that Simon uses compared to what we see here. So there needs to be, there's something in it, I think.
Okay, thank you for your question, Ian. We've got some more coming up in the chat. So Andrew Hugo is directly addressing one of the three areas that you wanted to get some discussion going on relating to the robustness of the MSA scores, diverse hearing profiles, and the multi-objective streams. Andrew's saying, to address the second question, I'd like to be able to rehearse and perform music again, having been unable to do so since 2007 due to hearing loss. Perhaps EQ transforms could offer a real-time mix that might work. What are your thoughts on that, Kai?
Yeah, I mean, the spectral domain is obviously something that bears a lot of potential, and individualization is obviously a key ingredient there. I'm not so sure how the question relates to real-time processing, or whether this is something that people also sort of can adapt to in advance, or adjust in advance and then adapt to while hearing and performing music with it. But I think for the spectral domain, we're really just at the very beginning of music individualization.
Thank you, Kai. And there's another question here around, has there been research investigating what aspects of music make it more enjoyable for diverse hearing listeners? Perhaps there are qualities that are more important than target instrument or melody detection.
Yes, so I mean that's a great question, because it summarizes also a bit of the conclusions of my talk, I think, because if we just look at single measures, then we might prematurely conclude that specific settings are valuable. For example, in this case, the hearing aid compression setting, if we just had looked at MSA performance, then fast compression obviously would have been the best way to go. Now we know slow compression optimizes sound quality for many listeners. So we somehow need to find a way to negotiate between these measures. And I think in the next few years, we should think more about what the interesting measures are, complementary measures to assess this. And especially we need to find better data on individual preferences. So as of now, we don't have any data of how preferences of listeners are distributed according also to their perhaps background, you know, and this is something to work on, in my opinion.
Okay, thank you. There's some more questions in the chat. I'm just going to be naughty and just insert one of my own quickly. Would it be possible for sort of composers and producers to compose music that maximize those segregation cues, do you think?
Yeah, that's a nice question. I think composers are very well aware of all this stuff, perhaps implicitly. Perhaps they haven't read Bregman or Huron, but they are very well aware that clarity plays a role. And this, I mean, you can see this directly in for example, David Huron's writing on polyphonic music and voice leading, how these rules of voice leading directly cohere with scene analysis principles, right? And in other styles of music, I think this is also something that is implicitly hidden in the music. So I don't think any composer really forgets about auditory scene analysis. I think the fascinating thing about it is scene analysis principles are, in my opinion, ingrained in every step of music making and production. So composers think about it, then performers think about it a lot. You know, they practice a lot to get their onsets at the same time in order for the ensemble to be able to fuse. Music producers, record engineers, they think about it a lot, how to achieve this particular stratification of different musical elements and layers. So it's really ingrained in every step of music production. And the interesting thing is, I think in music psychology, we often listen to we don't listen to bad music enough. Because music is always like we listen to these top products of cultural production, you know, this is at the very top level. But if we listen to stuff that contains some suboptimal choices and suboptimal settings, then one can really become aware of the flaws and the problems that arise there. So, for example, if you listen to children bands, then or beginners ensembles, then you will instantly notice how difficult it is to organize the musical scene into something that's coherent. And I think this illustrates that, yeah, ASA really permeates music from beginning to end.
Thank you, Kai. There's quite a number of other questions, and so what I'm going to do is I'm actually going to try to group them, and we'll perhaps got time for two or three more. There's one question about, you know, I was wondering if the genre of music could make a difference here, and another comment about, you know, there's a large diversity in music material. How do you choose the music material for testing? To what extent can we be certain that the presented results extrapolate to other musical material across genres or even within the same genre?
Yeah, so this is a very interesting topic. Obviously, music is so broad that it's really hard to define. In this case, we use material from the medley database, which is relatively broad and perhaps reflects a bit of mainstream Western listening preferences. We also used a comparison of popular music excerpts and classical music excerpts in the test with hearing aids. There we saw that people like pop music better than classical music for some reason. but we didn't see any interesting interactions with other conditions or other factors in the experiment. So there was not really something to report there. I think the diversity, also the acoustical diversity of music is a basic starting problem for this whole domain, music and hearing aids. Why it has taken so long to get it started is that music as a signal is so diverse, it's really hard to pin down the essential acoustical qualities. And in this study with Christophe that Christophe Lesemple reported last time about, we also saw that the diversity within musical pieces and across musical pieces, even within a genre, are so strong that it's hard to draw definitive conclusions.
Thank you. Any thoughts about a MSA test for orchestral music, perhaps? Just thinking about how difficult that would be. But you know, brilliant that would be. Okay, I want to read another one out that answers one of your, or addresses one of your questions. Nick Beresfeld, who said, "Thank you for your very interesting presentation. With respect to multi-objective optimization, have you tried multi-dimensional scaling like PCA on your data? Subjects may focus on different aspects of sound quality, so there might be different, perhaps subjective underlying dimensions that can play a role and describe your data."
Yeah, it's a good point. So what I reported on today was really just our one-dimensional sound quality ratings, and sound quality is, of course, also a multifaceted thing, and there are so many different aspects to it that we could also analyze. But this is really subject for future research to cover this. I think the semantic dimensions of music sound quality with hearing aids that Scott and Alinka have described recently are a good starting point for this.
Brilliant, thank you. There's one very quick question and a comment. So I think we'll just, if you could just be quite quick with your answer to this one. It's from Johanna, and it says, "Has the MSA test been used to test how well scene analysis is implemented in hearing aids or CIs? So selecting different musical scenes, speech and noise, music using different microphone modalities." So basically, I think that's a question about cochlear implants, and have you used it with any cochlear implant users?
Yes, we did. We haven't really written down these results, but we have data from something like 12 CI listeners, and it worked surprisingly well. So they performed in the lower range of hearing aid users, so unaided hearing aid users, but they were all able to do the task. So that was also surprising to us that this seemed so straightforward to them, but it worked out.
Fab, thank you very much. And I just want to finish by reading a comment out by David Huron, who said, "When results are so counterintuitive, it usually means that there is some new phenomenon to discover. I hope you're able to continue to pursue this line of research. There's probably something unexpected and important to learn." And I think that's, thanks for that comment, David. And I think that's a really good place to stop and to say thank you very much to Kai. Round of applause. I'm sure other people are clapping as well. Thank you very much, and I will move on to introducing the next speaker, who is Sam Kuth. If you want to stop sharing your screen, Kai, that's it. You come on up. So Sam is a lecturer in the Manchester Centre for Audiology and Deafness. His background is in sensory perception, investigating how the brain processes different sensory events to coordinate behaviour, including vision, touch and hearing, and how this might be altered across the lifespan and in clinical populations. He has a particular interest and expertise in musicians' hearing, which includes exploring how prolonged noise exposure affects hearing abilities, noise legislation, how we can measure hidden hearing loss among musicians, and hearing conservation practices, so musicians' attitudes towards wearing hearing protection. He's published his work in the International Journal of Audiology, Hearing Research, Frontiers in Neuroscience, and the International Journal of Environmental Research and Public Health. I feel very privileged to be working with him on our project, our current project, which is exploring perspectives on audiological practice for musicians in the UK context. So take it away, Sam.
Thank you, Alinka. That's a very nice introduction. So yeah, as Alinka explained, this is some work that we've been working on together, but it is primarily a master's dissertation project. So our student Mark Smith was working on this a couple of years ago. So yeah, I'm just going to present some of the findings from his dissertation today, and Alinka and I have been kind of building on that to kind of create it into a slightly bigger story. So I'm going to start off by talking a little bit about musicians' hearing. Now, I know we've got several musicians in our audience today. I've just seen in the chat there's been some talk about hearing loss amongst some of these musicians in the audience, and there's been some chat about how it can affect performance abilities, which can also affect their enjoyment of music. And in some cases, in extreme cases, it can lead to a loss of profession as well. So obviously, it's very, very important that musicians look after their hearing, not just for their well-being and enjoyment, but also for career longevity as well. So audiologists are trained to prevent and diagnose and treat hearing. So obviously, they're in a very good position here to help our musicians look after their hearing health. Oops. So there's been quite a lot of attention recently about hearing loss in musicians. It feels like every other week there's a news article somewhere about a famous musician that's lost their hearing. So we've got Katie Tunstall here, Dave Grohl, the Gallaghers, Miles Kennedy, Chris Martin. So these are mostly pop and rock ones. But then there was also the Chris Goldschneider case a few years ago, and the legal case that he took out against the Royal Opera House. And a couple of years ago, there was this Oscar-nominated film, The Sound of Metal, which was about a drummer who lost his hearing as well. So it seems like there's coming a lot more attention paid to the impact of noise on musicians' hearing and musicians' hearing health more generally. In terms of research, there's also been quite a lot of research on this recently. There was this really nice systematic review a few years ago by DiStadio et al. And they showed that 39% of musicians had some sort of hearing problem, noise-induced hearing problem. And this is compared to approximately 25% of people in the general population. So it kind of suggests that musicians are in a higher risk of noise-induced hearing loss. But despite these higher risks, musicians are sometimes reluctant to use hearing protection to protect their hearing. There's a study from nearly 20 years ago that suggested that consistent use of hearing protection was as low as 6%. I think since then we've seen a little bit of a change in the culture, and the numbers are increasing. So some studies are reporting around about 50-60%. So it's going in a positive direction, but I think there's still quite a lot of room for improvement there. There's this initiative called the Sound Practice Project in Australian orchestras, and it has various different kind of initiatives to try and get musicians looking after their hearing health, one of which is the provision of custom molded earplugs and annual hearing tests from an audiologist. And what they've seen with these different measures is that it's increasing the use of hearing protection devices amongst these orchestral musicians. And what this seems to suggest is that when you've got an audiologist involved in helping musicians look after their hearing, they're more proactive in using earplugs and looking after their ears. So there was a study that came out in 2018 by McGinnity and colleagues, and they wanted to look at what are Australian audiologists doing when it comes to providing services for musicians? And they found that only 1 in 5 of these audiologists kind of knew what level of attenuation to recommend for hearing protection devices for different instrumentalists. The participants in this study, the audiologists in this study, were mostly musicians themselves, so there was quite high confidence levels. Nevertheless, approximately 80% suggested that they would benefit from sort of upskilling course. And I think the main take-home message from this particular study was that there is a need for evidence-based best practice guidelines and training for audiologists for providing services for musicians. Now, obviously, this is in Australia. They have a completely different health service to what we have here in the UK. So I think an interesting question is, what are our audiologists doing in terms of providing care for musicians, and what are the barriers there? So I focused on conservation now. I'm just going to take a sidestep into more of Alinka's realm here. So I'm going to let her butt in and correct me where I go wrong here. But I'm going to look at rehabilitation for a moment. And we know that hearing aids and other assistive devices and kind of tinnitus counselling are very, very beneficial for musicians. Obviously, hearing aids are there to improve audibility. As we've seen from Kai's talk, that potentially there's the opportunity there to pick out different musical elements and different instruments for those with hearing loss. But despite these kind of incredible advances in technology, there are still issues with hearing aids for music, and musicians are quite often reporting that they experience distortion or poor sound quality, and this can be due to different compression ratings, as we've just seen from Kai's talk. And because of this, when musicians are reporting on their experiences of audiological services, they're quite often saying that their needs are not always being met. Now, the HearMus project, the Hearing Aids for Music project that Alinka leads on, they've generated these wonderful resources for audiologists. And it helps the audiologist to tailor hearing aid settings and counselling to kind of improve the expectations for musicians in terms of what the possible outcomes are, and kind of let them know that perhaps they're not going to hear quite as well as they used to prior to having any sort of hearing problem. And not only is this beneficial for the musicians, it's very beneficial for the audiologists as well. So the audiologists that have used this have said that their confidence has increased in terms of fitting hearing aids, and 95% agreed that they're more confident in fitting hearing aids. Those with training were more confident overall in providing advice and fitting hearing aids. But these resources were developed as brilliant as they are, and obviously I'm not going to badmouth any of Alinka's work while she sat here in this talk. But there needs to be more of a systematic approach to actually find out what are the barriers for audiologists to deliver services for musicians more generally, both for conservation and rehabilitation. And there's been several different guidance documents developed, including the ones from the HearMus project. Another one that came out of the American Academy of Audiology in 2020. And this was the opinions of a small group of clinicians who specialize in musicians' hearing. And they kind of came up with some recommended procedures, mostly based on hearing conservation and fitting hearing protection devices, custom molded hearing protection devices for musicians. But what's not clear from this clinical consensus document is, are all of these different practices actually being used by audiologists? How simple are they to use and implement? And it's not clear how non-specialist audiologists, so people who don't specialize in musicians' hearing, are actually implementing these things, and is it feasible for them to implement these different recommendations from these audiologists? Some of the research that we've seen previously, such as the McGinnity study, they tend to look at audiologists who themselves are musicians, but I think it's important to gather insights from a wide variety of audiologists from different backgrounds, so different levels of expertise and experience, different working environments. So, for example, those who work in the NHS or those who work in the private sector or charity or where it is they might work, and also musical backgrounds as well. So those who have a musical background tend to be more motivated and interested in this sort of thing, and they tend to have a higher level of experience and expertise. But we need to understand what the barriers for those with less expertise in this area. And I think what's important about these other clinical consensus documents is that they've not necessarily been developed with any kind of theoretical framework to understand what the barriers are to providing services for musicians. And that's exactly what we want to do in our research. And in particular, we want to use this particular model, which is called the behavior change wheel. And this is a tool that provides a very kind of methodical and systematic approach to developing behavior change interventions. And I just want to draw your attention to the green hub at the center of this wheel. And this is something called the COM-B model, which stands for capabilities, opportunities, and motivation. And these are the three things that dictate people's behaviors. And we can break these down into various different components. So capability are things that are internal to the individual. So we've got psychological capability. So this can be, for example, audiologist knowledge of hearing aid settings for music programs and that sort of thing. And also physical capability. So it could be audiologists' skills in fitting hearing protection, for example. So things that are very internal to the individual. And on the flip side, we've got opportunity, and these are things that are external to the individual. So it can be physical opportunity, so having time, staff, resources, equipment, and that sort of thing, which allow them to provide services in a way that they would like to. And then we also have social opportunity. So these can be the influences by the people around them. So their team, their friends, family members, that sort of thing. So where there might be stigma or kind of social expectations and where things are seen as taboo, that can influence people's behaviors. And then finally, we've got motivation. And these are more kind of like the cognitive processes that dictate behavior. So we have reflective motivation. So these can be things like people's beliefs, their goals, their intentions, their professional identities, and then automatic motivation as well. And this is more related to people's kind of emotional responses, which drive behaviors. So if they're stressed or anxious or scared, that might kind of prevent them from behaving in a particular way. But it also incorporates things like conditioned responses. So people just behave automatically depending on the context that they're in. So this is a really nice model for, first of all, understanding why people behave in particular ways, what are the barriers to them behaving in particular ways. And then based on that, we can use these other parts of the circle, which I'm going to come on to a little bit later, to develop our interventions. The aim of this particular study was, first of all, to understand the current practice of audiologists delivering services for musicians in the UK. But importantly, we wanted to use this COM-B model to find out what are the barriers for audiologists providing high quality care for musicians. How did we do this? Well, again, this was all Mark's work. He conducted a survey on Qualtrics, first of all. So he wanted to assess different practices in terms of consultation, rehabilitation, and conservation. So this is kind of modelled on that McGinnity paper that was conducted on Australian audiologists. But to kind of build on this, Mark also wanted to look at what the audiologists' attitudes and beliefs and confidence levels were in terms of providing care for musicians. And importantly, we wanted our audiologists to rate their different COM-B domains. So how much physical opportunity they felt they had, how much social opportunity and motivation and capabilities and that sort of thing. And they rated these on a scale of 1 to 10. And to supplement the survey, Mark also conducted semi-structured interviews with some of these audiologists that had completed the survey to really kind of get a lot more kind of detail and kind of find out what the nuances are of these different barriers and facilitators to providing care for musicians. And he kind of structured his interview based on something called the theoretical domains framework, which is essentially a way of breaking down the COM-B into slightly more manageable chunks and kind of slightly more direct questions. So we used that to kind of help us draw out the themes for the barriers and facilitators. For the survey, we had 49 UK audiologists take part, 39 female, quite a wide age range, so from 22 to 57 years. The majority of these were working in the NHS. There were some who worked purely in the independent sector, and we had 18% who were mixed. So this could be a combination of NHS and independent sector, or it could also involve working in academia or kind of charitable sector and other things as well. Importantly, we captured a wide range of experience. We had those who were kind of 1 year into being an audiologist or were still training to become audiologists, and we had those who had well over 20 years experience and were kind of operating at the consultant level. And we had kind of quite a mix of different musical backgrounds. So about half of our survey sample had some musical backgrounds, and this ranged from kind of very amateur musicians or those who had prior kind of formal training when they were younger, to those who were still practicing or semi-professional musicians at the time of doing the survey. In terms of the interview, we had 9 participants take part, 6 female, similar sort of age range again, a good range of experience, including trainee audiologists up to those who were at the consultant level, and 6 of these had a musical background. Again, some were kind of still practicing as musicians, and some of these had kind of very limited experience in music. Coming on to the results, the first thing we wanted to find out was how often audiologists were encountering musicians in the clinic. And from the survey, it would seem to suggest, let me get my pointer out here. Approximately 2/3 said that they saw musicians at least quarterly, and around about a third said at least monthly. I apologize for the use of pie charts. I found out recently that apparently people don't like pie charts, but yeah, I do. I apologize if you're one of these people that doesn't like pie charts, but there were a lot more in this presentation. I've managed to get rid of quite a few of them, so hopefully it's not too jarring for you. We also asked our survey participants what types of musicians they typically encountered. More often than not, it was amateur musicians, but quite often they also encountered semi-professional and professional, and quite often retired musicians as well, as you would expect, especially given that aging is related to hearing loss. So you might have a lot of people who are ex-musicians who are coming in for age-related hearing problems. What was interesting is that the interview data didn't really fully support what we're seeing in the survey data there, in that these 9 musicians that we interviewed didn't see musicians as often as, these audiologists that we interviewed didn't see musicians as often as the survey data would suggest. So they mostly reported that they rarely or never see musicians. And this creates a barrier in itself, in that they're not able to generate the experience that they need and learning through practice. So I've got a really nice quote here from one of our audiologists. In terms of the musician side of things, I can't say I have much experience. That's potentially because I'm not asking the questions I need to ask about whether someone is a musician, but it's never come up in sort of social history that I've asked, so very limited. So it suggests that they're not seeing many musicians here. In terms of the different services that our audiologists were providing, on the left here, I've got some data from the survey. And more commonly than any other service was the provision of hearing aids. So it's about 95%, I think, of the survey participants said that they were providing hearing aids for musicians, followed by hearing health assessment and hearing protection advice. But you can see actually the provision of hearing protection is very, very low. We also had other selected about 20% of the time, and quite often this was related to tinnitus counselling for musicians. And the interview data seemed to support this to some extent. And it seems to suggest that the kind of emphasis for providing care for musicians is on rehabilitation rather than conservation and protecting hearing. And this could stem from a couple of things. Well, one is a lack of training in conservation, and this could be due to conservation being seen as a lower priority at various different levels. So this could come from the NHS level and, you know, the employer level, or it could come from the department. It's also from a kind of a training level. These audiologists are more likely to have been taught about rehabilitation than they are conservation. And it could be individual priority as well, in that they kind of would prefer to focus on rehabilitation than they would on conservation. And I've got another quote here, which I think supports this quite nicely. So it's, "The other thing that I never really thought about until you mentioned it was hearing protection, because I always think about helping the problem rather than avoiding the problem. And I think we do need quite a bit of CPT in hearing protection, and we should know more about it. And especially the earplugs that we give them from the company. We should know about the filters. I know nothing about them. We should know that." So this really attests to the fact that these audiologists are kind of primarily trained in rehabilitation, but not so much in conservation. When we asked about how often they ask musicians about different kind of things relating to their musical practice in terms of instruments played and the genres and what have you, we saw the audiologists were quite often asking the musicians about what instruments they were playing, about whether they used hearing protection, and they asked about noise exposure levels, but they didn't as commonly ask about what genres they were playing, how long they played in terms of the number of years, how often they were playing their instruments in terms of hours per week, and very few asking about the use of in-ear monitors as well. And this seemed to come out in the interview data as well. So our audiologists weren't routinely asking about musical practice, and this might be because they didn't know what topics they were meant to cover when they were speaking to musicians, and this could be due to a lack of knowledge in this particular area. And it could also stem from the fact that none of our interviewees reported there being a standard operating procedure for dealing with musicians or dealing with music listening in general. So this quote is, "A really easy thing to do would be just to have, do you play an instrument? Do you enjoy music? What's your relation to music? That should be part of our standard procedure." So I don't think this audiologist is thinking specifically about musicians, but thinking about asking all patients about what their relationship is with music and kind of optimizing hearing aids for them based on those responses. Another thing to note is that because there's not this standard operating procedure, a lot of our audiologists weren't necessarily asking patients whether they were musicians or not. So the reason why there's this kind of low frequency of encountering musicians might be simply because they weren't asking. So it could be that they were encountering far more musicians, but they didn't necessarily know that their patients were musicians. And this quote kind of just backs this up nicely. The reason we don't hear about it is because we don't always ask about it. So again, if this was part of the standard operating procedure, it could be very effective in terms of figuring out how many musicians they're seeing and then tailoring care accordingly. In terms of the audiological assessments that were carried out, this very much backs up what was seen in this McGinnity study. So nearly all of these audiologists in the survey were performing otoscopy and PTA, around about 50% doing tympanometry. But then when it comes to these more kind of advanced diagnostic assessments, so extended high frequency thresholds, acoustic reflex thresholds, speech testing, speech and noise testing, otoacoustic emissions, upper loudness levels, we can see there's a lot more variability in terms of how often these different assessments are being carried out. And this was supported by the interviews as well. And we kind of dived into this a little bit more to find out why they're not performing these different assessments. And kind of unsurprisingly, the things that came out are lack of time, lack of resources, lack of funding, lack of staffing. And I think this quote is really, it hits the nail on the head. So this person says, time and staff, particularly at the moment. I wouldn't have said it's always an issue, but particularly at the moment, it's just an absolute nightmare. We're struggling to do the basics, let alone the more advanced stuff. It's just very, very, very difficult when you've not got any band 5 audiologists, for instance, which is basically where we are at the moment. And this isn't just in relation to providing services for musicians. In other studies that have looked at barriers for providing different elements of care for audiologists, this seems to come out again and again. Something that was quite interesting is that a couple of our audiologists pointed to someone within their department who had some sort of musical background. And this meant that there was someone who they felt had the expertise that they could pass patients onto or refer patients onto. So a potential facilitator in terms of providing care for musicians is having this departmental music champion. And this is a quote that says, yeah, because where I trained, there was this one audiologist who was a musician, and we used to give all the musicians to him, and he was like the musician guru in a way. So I really like that. We need more musician gurus, apparently, in our NHS audiology clinics. Just to add to this, there were a few of our interviewees who suggested that not all the responsibility should go to one person, and they felt that it would be good for all audiologists to have some degree of knowledge and training in providing services for musicians. And they also pointed out that if there's one person who specializes in this, then it kind of takes the responsibility off everybody else, and it means that then they're kind of being enabled to not have to do anything. They can kind of become bystanders in a way. So it's not necessarily always helpful to just have that one person who always deals with all the musicians. And what happens if that person leaves or comes ill, for example? There needs to be kind of shared responsibility amongst the group. So in terms of providing guidance and counselling on different topics, we can see that more often than not, the topics were related to hearing aids and hearing loss more generally. So this relates to rehabilitation. There's some conversations on noise exposure, but when it comes to protective behaviours and the use of hearing protection devices, we can see that is much less common in our survey participants. And they were asked about whether they recommend different types of hearing protection and different attenuation levels and what their different procedures were and whether they did these or not. And we can see that, more pie charts here, that around about 2/3 people of our audiologists said that they did know what type of hearing protection devices to recommend to our musicians. Around about 2/3 said that they didn't check the attenuation levels. Nearly all of them said that they didn't fit hearing protection devices, and none of them verified the attenuation levels of hearing protection devices. In terms of knowing which hearing aid type to recommend to musicians, it was around about 50-50. 50% said, yes, I do, 50% said, no, I don't. And some free text comments kind of expanded on this. And basically, because there's a set type of hearing aid for certain clinics or use in the NHS, basically patients get what they're given. So the audiologists don't necessarily have a lot of say in what type of hearing aids go to musicians. But when it comes to settings, if they knew what types of settings to provide in hearing aids for musicians, around about 2/3 of our survey respondents said yes, they did know what settings to use. But then that still leaves a good third who said, no, I don't know what settings I should be recommending for musicians. And this kind of came out in our interviews as well. And it kind of stems from this kind of lack of confidence, and which could come from a lack of experience as well, especially those who have not been practicing for many years. So this person said, personally, I'm not very confident. I could talk to them about it, but I think anything I did would feel a bit like trial and error. It wouldn't be me going, this is definitely going to help with that. So they're not sure, they're not certain about providing care for the musicians or fitting hearing aids and providing the right settings. Some of our participants were aware of Alinka's work on the Hearing Aids for Music project, and they were aware of the resources that had been developed, and they pointed to these directly and said they were very helpful. So one potential facilitator to providing care is having some sort of guidance and resources. And nearly all of the interviewees, and in fact all of them, did say that they would value some sort of upskilling course. So this quote says, "I think training, even just like short webinars in the NHS, that's a really good way of getting training quickly. They can give you an hour to watch a webinar, but they don't necessarily want you vanishing for a whole day." And again, this kind of taps into this barrier that there are time constraints on NHS staff, and they can't just go off for days on end and do these really intensive courses on musician services. It needs to be kind of bite-sized, short CPD modules. Just carrying on in this same theme, one of the barriers to providing care to musicians was that the audiologists felt they couldn't really see the same musicians over and over again, or they didn't always have the continuity of care with those same musicians. So the musician would come in and they'd go off to a different audiologist each time. And that made it difficult to track the kind of rehabilitation pathway. So this audiologist said, you try and follow up with them yourself, because it is also helpful for you to see whether the changes you've made have had any benefit for that person. But in the NHS generally, it is quite difficult to get booked. I mean, there's no audiologists anymore, so no one is getting booked in with anyone. But it's quite difficult to follow up with the same patient and get that continuity of care going. And another thing that our interviewees pointed out was that they didn't necessarily see musicians as special patients, no more special than any other general patient that they get in. But they did point out that for everybody, there needs to be patient-centered care. So all care needs to be tailored to that particular patient's needs, whether they're a musician or not. And this particular audiologist said that they take a slightly different approach if someone says that they are a musician, in that they ask them to bring their instrument into the hearing aid fitting appointment. So the quote is, when they mention music, just taking a different approach, much more involved approach with the music, you know, like getting them to bring their instruments in, and it's brilliant when they bring them in and they love it. It's just been such a good positive follow-up appointment or fitting, because you just get to actually like hear the instrument, and they can play different songs, and you can do the fine tune, and then they can listen as they play, and then it works. So, you know, tailoring the appointment to each musician's needs or each patient's needs more generally is a good facilitator to providing care. In our interviews as well, we kind of wanted to look at meeting the needs of musicians and what were the barriers to doing that. As we've seen from Kai's talk, one of the main limitations is that, one of the main barriers is that hearing aids are limited in terms of their capability of restoring music. And this can lead to low satisfaction ratings for our musicians. And there's also this belief amongst our audiologists that musicians are difficult patients to work with because they have these very complex needs and they want to be able to hear as well as they once did. And there's also some communication barriers between audiologists and musicians as well. So where an audiologist might use the term frequency and a musician would use the term pitch. So there can be a bit of a communication breakdown there. And this quote, I think, supports these points very nicely. So they all said, oh, musicians are so difficult. They have demands. Either we don't understand them or they're completely unrealistic. And so they all said they're very afraid of having a musician as a customer or as a patient. And this, for a couple of our interviews, said it has an emotional impact on them in terms of producing stress and anxiety. So this person said, I feel automatic stress, and I automatically feel I can't provide you with enough. I automatically feel like I'm not good enough to give them what they need in a way, and it's like unfair. So that, I think that's pretty interesting, that the emotional response is a reason why our audiologists are not wanting to deal with musicians and to provide care for them. To overcome this, some of our facilitators are setting expectations for the musicians. So some of them reported that they just need to kind of provide realistic expectations in terms of what the hearing aids are capable of, and also when it comes to conservation, how hearing protection devices might influence the perception of the music. And they also pointed to trial and error. So I think we saw this in one of our earlier quotes, where they were saying that they'd get their musician to bring the instrument into the consultation, get them to play, and then they would fine-tune the hearing aid settings until they were right for that particular musician. And going through this trial and error process seems to work in terms of meeting the needs of each musician. So what I'm presenting here are the ratings from the different COM-B elements. So we've got the capabilities along the bottom: psychological capability, physical opportunity, social opportunity, reflective motivation, and automatic motivation. And our participants were rating these on a scale of 1 to 10. And what you can see is that the lowest rated ones are psychological capability. So these are things like knowledge of the subject area. Physical opportunity, so these are resources, staffing, time, that sort of thing, things that are external influences on the individual's behaviour. Social opportunity as well is quite low, so the team around them can influence the way in which they behave. And what we did was we took all of our different barriers that we identified from our interviews. I've not covered all of these today, I don't think. You've probably seen a lot of them. And we've assigned them to 6 different domains of the COM-B. And you can see that most of these barriers are falling under this physical opportunity element of the COM-B model, followed by reflective motivation. So things that are external to the individual are having a large influence, and also their kind of internal thought processes as well, in terms of their beliefs and their capabilities of providing care for musicians. That's having a large influence on them not providing the care that they're meant to. And then in terms of facilitators, we've done the same thing. We've categorized them according to the COM-B model. And most of the facilitators are falling under this psychological capability. So it could be, having the training or having the resources and having kind of the support network around them that allow these audiologists to gain the knowledge that they need to provide care. And then that's followed by reflective motivation as well. So kind of trial and error, setting goals, having discussions with colleagues. These can all lead to kind of thinking about their own professional standing and providing care for musicians. So just to summarize, what we've seen from both the survey and from the interviews is that services tend to be focused on rehabilitation rather than conservation. And this seems to come from various different influences from above in the NHS to also, the training courses and degrees that these audiologists have taken. And there's various different barriers and facilitators to providing care. And it seems like most of the barriers relate to the physical opportunity, so time and resources, and also the reflective motivations. It can be things like the lack of confidence. When it comes to facilitators, it seems that these mostly relate to capability. So those who were more confident and felt like they were better at providing care for musicians seem to suggest that they'd had some sort of training or CPD. And they also had higher or more reflective motivation. So they were thinking about what their kind of goals and intentions were and relating that to their kind of professional identity and thinking about what that means to them. So what we're going to do next, well, I showed you that model of the behaviour change wheel before. What we've done so far is we've identified the green bit. That's all the the barriers and facilitators to providing care. And now we need to kind of work our way outwards on the other rings of the behavior change wheel to develop an intervention that we can test and evaluate in terms of how effective it is for improving services for musicians by audiologists. So I've got like a very quick work through example here. So we've identified from this study, one of the barriers is having no standard operating procedure for dealing with music in the audiology clinic. And we've categorized this in terms of physical opportunity within the COM-B model. Now, with the behavior change wheel, there are certain things that are certain intervention functions, which are kind of broad categories of interventions that are specifically linked with physical opportunity. And it's up to the developer of the intervention to decide which of these intervention functions they think is going to have the most traction. So, for example, we could pick environmental restructuring. And then the next step in this behavior change wheel is to kind of pick out more specific examples of techniques that you can use in your intervention. These are called behavior change techniques. And there are specific behavior change techniques which have been linked with specific intervention functions. So it's kind of like a paint by numbers process. It's very methodical. For some of these, for example, links to environmental restructuring could be access to resources, providing environmental incentives, restructuring the environment. So this could be the physical environment, but also the social environment. So thinking about the teams that these audiologists work with as well. So we could, for example, pick access to resources as well. So this could be very simply developing a new SOP that has questions related to music listening in it. Importantly, when we are generating these behavior change interventions, we need to apply this thing here called the APPEASE criteria. This stands for accessibility, practicability, effectiveness, affordability, side effects and safety, and equity. So we would assess each of our intervention functions and each of our behavior change techniques in terms of these APPEASE criteria in order for us to decide which we think is going to have kind of the biggest effect and is going to be the most affordable and accessible and what have you. What's really, really important is that when we are developing these interventions is that we involve the stakeholders. And this can be the audiologists directly, it could be the employers, it could be policymakers in the NHS, and also our musicians as well. So it needs to come from multiple perspectives to kind of really channel these interventions to make sure that they are very effective. So that's me. Thank you very much for listening. As I said, any difficult questions, please send those to Alinka, but otherwise I'm happy to answer any of your questions. I'm just going to pop a light on. It's going to be a bit dark in here.
Thank you so much, Sam. Okay, so I'm pulling up the chat. There isn't any questions specifically at the moment. Oh, hang on, we've got a thank you from Lorenzo in the chat. Just while people are thinking of any questions that they might have, just add a couple of points really, just to say that, well, first of all, I mean, this has been brilliant research to be involved in, because it really does identify what those challenges are. And I just want to sort of emphasize that we're not pointing the finger at audiologists here and in any way and saying, oh, you don't know what you're doing, or you don't have the knowledge, or, if you're not taught about something, then it's very difficult to be knowledgeable about that and to have confidence in that. So I think a piece of work that was done and that I was helped with by Matt Frost, actually, who I can see is on the call, was to have a look at the audiology curriculum and to have a look at the content of the curriculum. And there are very few audiology courses in the country that actually have any specific tuition on music. It might be like one module on music perception, for example, or the acoustics of musical signals. So it's very difficult to be knowledgeable and confident about when you haven't been taught. But what we are seeing in our data, and it's something that I've seen in my previous work, in the HAFM work as well, is that even a small amount of training can go a really long way. In, you know, whether it's advice leaflets or, as these audiologists are suggesting, some kind of short online training sessions, some kind of CPD that can just help them to, you know, give the latest evidence on what we know. And so, for example, we might be saying something along the lines on one of these courses about, okay, so there's been some recent experimental work which is showing actually that people are able to hear out instruments from a mix better if they've got fast acting compression you know, for their hearing aid settings. So it's a case of sort of understanding where we're at and conveying the knowledge that we have at the moment to audiologists. The second point I wanted to say, just on record, is just to say thank you to all of our audiologists for giving up their time here for doing the survey and also doing the interviews, because we know that they're quite time poor. So yeah, it's just been fantastic for us to get these insights. And obviously the goal now is to turn this into something really positive in terms of interventions for the audiologists.
Mm-hmm. Oh, obviously, yeah, you're absolutely right, Alinka. I entirely agree with you in terms of developing some sort of resources or CPD module or whatever it is. I mean, in an ideal world, what we would be doing is tackling the main problem, which is staffing, it seems like, and time and funding and all these extra things. But, you know, we would have to go shoot at the NHS overlords here, I think, and make changes there. And I don't see that being particularly feasible. So we need to kind of assess different approaches, and which perhaps is kind of smaller gains that we can make, but potentially very effective as well, such as, you know, like the HAFM materials. But maybe it could be the HAFM materials are very much on focused on hearing aids, but we could have something similar for provision of hearing protection as well, and, you know, providing counselling on protecting hearing.
Thank you, Sam. I think Kai's got a question. Do you want to come on and ask your question?
Yes. Thanks, Sam. That was very nice. You raised the point of hearing protection, and their confidence not only is an issue for audiologists, but obviously also for people who wear hearing protection. And there I was curious whether you know about any empirical work on music perception and auditory perception with hearing protection. So whether there's any baseline data addressing the question to which extent it affects pitch perception, for example, or loudness discrimination, stuff like that, which performers and high quality performers are obviously anxious about to lose, right? They're afraid of losing their sense of placement in an ensemble, for example, and their sense of whether they play at the right level. So I was curious whether you know anything about that.
Yeah, there has been. There was a study by MacLeod, I think it was, et al. A couple of years ago, and they looked at pitch perception, and they used different types of earplugs in musicians, so like foam ones, and then custom molded ones, and universal fit with kind of high fidelity filters in and that sort of thing. And they found that the foam ones were having a big impact on pitch perception. But then after that, when you had these kind of musicians' earplugs, the ones with the flat attenuating filters, it didn't have an effect on pitch perception compared to no earplugs at all, actually, as well. So there's this kind of preconception by a lot of musicians that if they wear any earplugs of any type, it's going to instantly ruin the experience for them. I'm not saying that's entirely wrong. From self-report, they would say, yes, it ruins the experience, it affects my performance, and I can't hear as well. But in terms of objective measures that have been done on this, it seems to have less of an impact than people think. But then I guess if you're a musician, you know, you strive for perfection. So yeah, even if you think it's having a minute impact, even if it in fact it's not, it's going to put you off using them.
Okay, cool. Thanks.
I can send you a link to that paper, Kai.
Oh, yes, please. Yeah. I just posted in the chat later on.
Okay. So we have a comment from Feresht. I hope I've pronounced your name right. You're just starting a PhD on audiologist perspective in fitting hearing aid for listening to music. Wonderful. Oh, it's really good to hear that that's the absolute focus of your PhD. Any recommendations for you? Well, I think that could probably come from either Kai or Sam or me, really. I don't know whether Kai, that's one that you, given your recent experimental work, how would you expand your recent experimental work looking at compression in an ideal world with funding?
You're asking that to me now?
Yes. Yeah.
Oh, yeah. I mean, one very interesting question is actually to make it a bit more difficult for the hearing aid to compress. So to look at more drastic level changes, for example, with classical music. I think you already suggested that, Alinka, to look at classical music. No, but to look at scenarios where you just have more drastic level changes, and this could be an interesting next step, I think. So to sort of put listeners in the scenario of an acoustic performance, for example, acoustic chamber music or a symphony concert or something like that, and there to see how well different hearing aids really do the job, or different hearing aid compression settings do the job. I think this could be very interesting.
Okay. There's a comment from Lena, who has just launched a specific training module for audiologists, and there's some information about this on the Music and Hearing Hearing Aids website. Don't know whether, Lena, if you want to come on and say a few words about that. And then there's a question for Sam from Lorenzo afterwards. So I'm aware that we've got around 5 minutes or so. So if we could keep the next bits brief. But Lena, do you want to come on and just say a few words about your course?
I will try, but I have to let you know that I've had technical issues with sound today.
Okay, we can hear you okay.
Okay, so I'm assuming you can hear me. Yeah, okay. Samuel, great presentation. Thank you so much. It would be great to have a chat sometime, because we are clearly very focused on many of the same themes. So yes, I concur. Having been in hearing care practice for more years than I care to count, the confidence levels when it comes to music are low. And the feeling is that music patients are complex. They don't necessarily have to be. Musicians do have sometimes complex needs, but we can also have non-musicians with equally complex needs. So my feeling about this subject, having provided music rehabilitation for around 14 years now, is that there is some basic understandings that need to be have about music and hearing loss before we can start getting into some more complex and specific issues. And it is because the needs can be so diverse and sometimes bear no correlation to the audiometric picture, that I developed the Hearing and Music in Hearing Care Practice Prompt 5 Foundation course, the onus being foundation course, to give everyone a level of understanding on the subject that they could then work from to then tailor things to a more complex or advanced level. So that's the purpose behind the course. It is effectively about music rehabilitation, with emphasis on rehabilitation, because in hearing care, we quite often use the word rehabilitation without actually meaning rehabilitation. So what I mean by this is it's going beyond basic acoustic parameters, not just acoustic parameters. So it's looking more holistically at the various interrelated issues that come to play in music perception with hearing loss. My background in doing this is not just as a rehabilitationist, but as someone who's also profoundly deaf and a music lover, and having shared the journey of so many patients over the years with varying degrees of issues with their music experience. So really, that was, Alinka wanted me to say something about the course. That's hopefully something to get you started with on that. I've shared the link also in the chat, Samuel, just in case you would like to make that known to the audiologists that you are encountering in the project that you're working on. And I'm happy to chat at any point also.
Thank you
Brilliant.
so much, Lena. Yeah, we should connect, and we'll figure out how we can use this resource going forwards. It looks really useful. Thank you.
But this is an area in which you also, Lena, can use the evidence from the research in your in your teaching and your course as well. So it's a lovely connection there. We've just got a couple of minutes left, so we've just got a very quick one. Lorenzo, if you could, last question now. Lorenzo, if you could come up on and just ask Sam your question, and then I've just got a couple of concluding thoughts before we close.
Hi. Sorry, I'll try to be quick. I've been reading a lot about, the issues with hearing and musicians, and I've been trying to see from a slightly different side, because I've been a musician for 40 years, and I met thousands and thousands of musicians of all sorts who seem to be kind of, they seem to be emotionally involved on the basis of how loud music is. And that goes from classical musicians to metal musicians to dance people. So it seems that, when you're young, you only tend to enjoy music if it's loud. And obviously, as you get slightly older, your taste starts to get a bit softer, and it goes down along with your hearing. So the idea of using, hearing aids or filters or something like that to muffle your perception of music, has it been considered from a kind of emotional psychoacoustic response? Because obviously, if I go and rehearse with a rock band and I put something in my ears and I don't enjoy it, I'm not going to do it next time. And it's the same for, not only musicians, but listeners as well. You go to a dance club and, the volume is not exciting. Aside from other kind of social considerations that, you go out with people and there's the social thing. So the fact that you have something in your ears might prevent you from, interacting and all the other aspects. But is there any studies about how loud music has to be to create an emotional response, to see if they can be mitigated or not? I don't know if the question makes sense.
No, absolutely. Yeah. It's interesting that you've mentioned that. I've currently got an application in for a PhD project to actually look at that exact thing in terms of how earplugs can influence the emotional processing of music, and how that it could diminish the kind of emotional response to listening to music. In terms of the level of music required to kind of get that emotional response, there has been some research on this, and some colleagues in Derby have been looking at this, and it's to do with the level required to activate the vestibular system, the balance system in the brain, and to activate kind of the haptic sense, so the vibration sense in your body. And that can kind of cause an activation of the limbic system in the brain, and it kind of is very addictive. And people kind of become addicted to loud music. In terms of the exact level, I can't remember exactly what it is, but it varies depending on the frequency as well. So low pitch bassy music tends to activate these senses more so than the high pitched, high frequency music does. I can't remember what the exact level is. There's some work by Todd and Cody from a number of years ago, and they did look at the levels. I want to say it's around about something like 95 dB.
Yes, that's what I would have said. Yes.
Yeah, I think it's about 95. I'd have to go back and check, but it's reasonably high, that high enough to be considered damaging to hearing as well.
Particularly on prolonged times. If you go to a club night in a day for 8 hours, which most people do. So it kind of, I was thinking about in terms of like having a Ferrari and having to drive at 50 miles an hour. And there's this kind of, you know, perception that is lacking if music is not loud, which obviously causes damage. It also causes damage if you drive too fast because you're going to end up crashing. But it's a bit of a similar situation. It's a very difficult nut to crack, I think. Particularly if you're 16 and you start to play, you know, in a punk band.
Yeah, I agree. It's getting the balance right, isn't it? In fact, I think that's what the name of the project was that we put in. It's hitting the right note with earplugs, I think we've called it. And it's getting that balance between protecting your hearing and actually enjoying the music as well. And yeah, I don't think anybody's properly looked into that yet.
Great, thank you, Sam. I think, yeah, we're going to have to draw to a close at this point because we've gone just beyond 4 slightly, or 5, or, you know, whatever time it is, wherever you are. I just want to thank again our speakers and also the audience. Thanks for coming along and listening and for posing lots of interesting questions. So we really appreciate that. Just want to give a plug for our next seminar, which is on December the 18th, same time, so 2 o'clock GMT, 3 o'clock Eastern time, Central Eastern time. We're going to be hearing talks from Stefania, Serafin, Olberg, and that's going to be presenting research projects at the Multisensory Experience Lab. So developing technologies to help individuals with diverse hearing abilities. This includes virtual and augmented reality, haptic feedback, and yeah, just really excited for that talk. And we've also got Ellie Harding from Groningen, and she's going to be talking about the rehabilitative effects of musical training for participants with hearing loss, focusing on adult cochlear implant users, and then also older adults with mild to moderate hearing loss. So we'll circulate details of those 2 talks. We're really looking forward to those, and also this has been recorded, so that will go up on the website and we'll send the link round. But just another thank you to our speakers and to you as the audience, and we'll see you soon, hopefully. Okay.